I decided to start numbering my examples. So what we have here is f of x equals negative sine x. And we're going to see what that does. So I'm going to do a little bit differently. I'm going to show you. So what the negative does is it does a vertical flip. And vertical flips for sine graphs are a little bit interesting, right? So a normal sine graph maybe looks something like, so a normal sine graph looks something like this. And then if we vertically flip it, so that goes down and that goes up, it flips over the x-axis and it looks something like that. Right? So this over here, this was our original sine of x graph, and then this over here is our negative sine of x. So negative sine of x starts in the middle, but instead of going up, it goes down. So let's put that together. So we're going to say that f of x equals minus 4 sine x minus 3. So we could probably ignore the negative for a good chunk of it. Boom, boom, boom. And what we have so it went down 3. So we're gonna have a lot more space on this one. It went down 3. The amplitude, the negative is just a vertical reflection. The amplitude, this is still the amplitude over here. So the amplitude is still 4. So we go up 4 and we go down 4 to negative 7. And this is kind of our middle over here. With our 90, 180, 270, 360. And so we're going to make our sketch. So sine graphs, we start in the middle. But because it's a negative sine graph, instead of going up, we're going to start off by going down. And then to the middle, to the top, and then back to the middle. And so the negative sine graph looks like this. And it'll continue. I mean, I haven't been doing it much, but don't forget that these continue in both directions. Right, so if we were at the middle, bottom, middle, we would then be back at the top over here, and then back to the middle. If we continued on to 450, it would look something like that. And that's f of x is minus 4 sine x minus 3. Okay. So, now we're going to do example 9. So this is moving to the right. If you remember your transformations, this is what a move to the right looks like. For periodic functions specifically, we have a special name for this. We call this one a phase change. If you ever watch those Star Trek movies and they say they're out of phase, it's something along these lines. It's trying to do with this. Vaguely. I mean, it's science fiction, so it doesn't have to have a connection to reality. Okay, so it hasn't moved up or down, so nothing special happens there. So it's actually going to start at 0. The amplitude is 1, so it's going to go as high as 1 and as low as minus 1. What has changed is that instead of starting at 0, we've moved to the right. So we're actually going to start at 17. And then what we notice is that we go up by 90 every time. So if we have 17, the next one is going to be at 90 later, which is going to be 107, I think. Yes, plus 90, 197, 287. And we could go backwards too. If we went backwards, it would be not minus 90 over there. So this would be negative 73 and negative 163. And where are the points going to go? Well, normally the starting would be at 0, but now the starting has moved 17 to the right, so we start over there. We go up at there, come back down there, at the bottom over there. We're at the bottom here. We're back to the middle over there. Normally I probably would have gone one more, I guess, right? So plus 90 would be, I think, 377. And if we draw the graph, it would look something like that. And so what happens is there's been a phase change. The whole graph has moved 17 to the right. And of course, we can combine everything again. So if we combine it again, we're going to get example 10. So f of x equals 3 sine x plus 25 minus 1. Okay, there's a lot of things combined here. So we can combine all of these things. What are we going to get? We're going to get, making our graph. So first of all, let's do the central axis. So the central axis has moved down 1. So we're going to be at negative 1. And that's kind of our middle. Not kind of, I guess it is. It's going to be kind of, it'd be not totally. The amplitude is 3. We're going to go 3 up from there. So we're going to go as high as 2. And we're going to go as low as negative 4. So we've got those guys. Plus 25 means that it's moving, it's moving left 25. There's a phase change of negative 25. So instead of starting at 0, we're going to start at negative 25. 90 down from that would be minus 115. Plus 90, just make sure, would be 65, 155, 245, and 335. Where do we start? We start in the middle, which is along the axis, over there. We reach the top one segment later. It's a new word I just used. We'll do that more when we do horizontal compressions, like that. And then it comes down to the bottom over there. It might be tempting when you see points like this to draw it like that. Do not do that. Just remember it's always kind of flat at the tops and the bottoms. And there we go. That's the graph of f of x is 3 sine x plus 25 minus 1.